Okay, so in the last video, we had drawn this graph in front of us showing the area of Antarctic sea ice over time. And it gave me an idea of the long-term trend. That's what that black line is. So roughly it stayed about the same. And if I was going into more detail, I'd be talking about how this bit's slightly decreasing, it increasing, it slightly decreases, it decreases at a faster rate, slightly increases, and petering off towards the end. So that's my first part of my graph. And we're expecting a visual interpretation of this graph. If I click the type of graph again and scroll down, I can get the seasonal effects graph. Now the seasonal effects graph shows me two graphs side by side. The right-hand graph, this part of the graph, is looking at the average season. So I can see our average season starts off in January, month 1, with it slowly decreasing in the amount of sea ice and reaches the bottom value of around about February time. It's the lowest amount of sea ice, which makes sense because in the southern hemisphere that's the middle of summer, or the end of summer, really. Then between March and September, the amount of sea ice grows until we get to our maximum amount of sea ice, and then in October, November, and December, it's decreasing again. So that's my average season. On my left-hand graph, this is each year's graph drawn around the same point. So it's actually taking that long-term trend graph and cutting it up into 1 year chunks and putting it all on the same graph. So you can see which years had slightly more sea ice this year and which years had slightly less sea ice that year. And if I could, I'd be able to read the year that's printed in the same color as the line is drawn. The whole point of this graph is to see if the pattern is relatively stable across all the years that we've got. So if I look here, in this particular time, my peak was actually in August in that year, and normally it's in September. So it appeared 1 month earlier. Now, if I could find that year and find out something that was going on in that year, that might give me some way of showing some kind of relational thinking or even some insight that I need for those merit and excellence grades. So that's an important part, and that's an important graph to be looking at to help you do that. I can also see that February generally is the lowest amount every single year. So that is also fairly useful for me to be able to make a statement that's fairly clear that generally February, even though we possibly would expect it to carry on into spring, into autumn in March, we would expect that to be about the right time. Remember that black line that went all the way through our graph last time, which was our average? It was our long-term trend. It was what we expected to happen. Imagine that in this average seasonal graph, the long-term trend line is at 0. So instead of it being a line that waved up and down, we'd fixed it as a straight line, and this was the seasonal effect going around it. That's what's going on. So I'm saying on average, in February, it's around about 6.75 million kilometers squared below my long-term trend. Whereas in month 9, I'm saying on average, it's about 6 million or 5.75 million kilometers squared above my long-term trend. Okay? So that's what we're having to talk about when we're discussing my my average seasonal effect graph. I can also look at my recomposition graph. Now this is a graph that has on the top my long-term trend, and remember I've still got my start and end point showing. It has the seasonal graph shown as a repeating pattern every single year, so I can see that, and it's put those together as a green line on this graph. So I can see where my green line doesn't really match my black line. So if I look here in 2003, my green line predicted to be much bigger than my actual value was. Whereas in 2006, my green line didn't go up as high as my actual value was. So I'm actually looking for differences to try and look at that. And I can see those differences even clearer on the residual graph, because the residual graph is the difference between my green line and my black line on this graph. So remember, the green line is a combination of your long-term trend being added to your seasonal graph, and anything that's different is not being explained by my model. So therefore, that's my residual. Okay? Right, so that's my average seasonal effects, looking at and then coming on to residuals. So we've nearly done all our graphs. Okay, next time we'll be talking about forecasts.